we're going to talk about natural language processing at the agency interface. The use case we're going to look at is how to make clinical trials easy for patients to access and use. The approach we'll take is reducing clinical trial recruitment burden by making data more machine readable and leveraging natural language processing. So this is a picture. I try to make a picture of all the agencies that we've kind of interacted with over probably the last 9 months as Presidential Innovation Fellows. All the solid lines are ones that we've actively been working on, and dotted lines are maybe potential ones in the future that we're just starting to form now. And really it's taken us really across a number of different agencies because each agency has a different type of expertise. You know, the VA, the largest medical integrated medical system in the country. Then you've got the National Cancer Institute with its cancer data, the largest funder of cancer studies, and each one has like a special feature that we've interacted with. And let me just start up, by saying, one of the things, we've learned about is that we found it useful to move away from sort of the one-way communication, which is, sometimes you can do through kind of like almost like setting a box over the wall, like an RFI, where you kind of get a piece back, you get a box back, but you can't really, it's hard to query it. So the other option is kind of listening session, sort of the other way, where you're kind of listening, but it's not as interactive. And so we've kind of moved toward, at least within the technical sphere, when you're looking at natural language processing and AI, this approach of having more of an iterative feedback. So round tables and stakeholders getting together, talking about policy and things maybe at the high level, but then iterating on those policies through collaborative pilot programs, hackathons, opportunity projects, things like that that can really go through and test out a little bit of policy at a time, kind of like a policy pilot, if you might want to call it that. I'm going to show you a couple examples where we used AI to incentivize good practice in clinical trials using NLP, as well as bringing together government, academia, and industry through a mechanism such as a hackathon. So one of the things that we did working with a couple different organizations within NIH, including NCI, was release some data sets. This first data set is about eligibility criteria. So if you look at clinical trials, the eligibility criteria tells you if that patient is qualified for that trial or not. And then the participants data, which kind of mimics the patient, that's the data that relates to the patient's needs. So when you're matching a patient to a trial, you need to kind of match these two. And so we released a version that took us a few months to kind of hand curate this data and then release it for one of these hackathons and other projects to test out how do you encode this data, what is better for NLP, how do you try things out. Well, when you look at the eligibility data, and here was really just a small portion shown over here, on the right, you can see that the eligibility language is not structured. The language is quite complex. In fact, the text can be confusing even for humans, much less machines. And the eligibility language itself is not standardized, so not structured and not standardized. And by standardized there, I meant by phrasings, for example, even if it's not structured. So we went about thinking about how do you encode it using logic, So let's say platelet count, the phrase might be the first line there, and then kind of color coding in terms of the different concepts, mapping them into ontologies like NCI Thesaurus, UCUM, we saw that ontology mentioned earlier, I believe, by the FDA, and then creating, and by looking through past trials, finding templates where these concepts appear, and then finding places where there are differences. So many times there's a platelet count greater than or equal to some number, which could be 100,000, maybe 75,000 in some other trials. And then sometimes they do it without transfusion, or they allow it with transfusion, or it has to be, there may be different limitations like that. So that's why it's a template. So just in summary, NLP and AI can really be found all over the place in this particular case of patient trial matching. I just added a final one just a few hours ago. So basically there's, matching the patients with trials, the actual match process can be using AI and natural language processing. The one that I'll talk about most in this talk is the idea of standardizing the protocol templates. That is, when you start to write the protocols, the authors who are writing the clinical trials in the first place to make it standardized in some way by using templates. We'll talk a little bit about that. The other approach is that you do it at the other side. After the templates are done, submitted, they're in the database, a curator uses manually curates or uses NLP to make suggestions to their curation, and then they structure the data in that way. And then number 4 is the patient data. You know, this was mentioned in the last talk. You can do NLP on the patient data, the path reports, all of those things to derive concepts that might help in matching them to the right trial. Chatbots, another interesting area, using speech recognition, voice synthesis, and so forth. And NLP, you can basically allow the patient to engage with an agent that can look through the protocols and give them feedback and so forth. So what I really wanted to focus in this little part of the talk is about how do you do incentivization of standardization through NLP. So we have a number of NIST people and others who may be interested in this, but the field, first of all, the field is very new in terms of clinical trials, right? There's new treatments all the time coming out. There's no incentive for writers of the protocols to use structured language because it takes time. But doing the structuring after the protocols are submitted is hard because those curators don't know the original meaning of the writer, and it's hard to scale the curation for all criteria. So NLP AI isn't really perfect for predicting structure either at that point. So one potential solution is to use AI NLP to find and present these templates based on a database consensus. It looks at all the other trials for consensus and phrasings based on text and frequency already used in the trial database, and presents that at the point of need when the people are originally writing the trial. And so the thinking is by doing this in a way that it can incentivize the people because you provide these templates to make the protocol writing faster than just starting from scratch, and it presents consensus scoring to encourage standardization. When they see what other people have done, they're more likely to use that language and phrasing when they actually are writing their protocols. And so part of that will be creating a database of these standardized phrases and criteria, and then variants, where the differences are, the fill-ins, kind of like in the MATLAB where you have fill-ins, which can more easily be structured. So then you just have a few items that are more defined and just a few variants off of that, and so then a curator can more easily manually structure just a few items. It will be much more scalable than what's going on right now. So our potential outcome is this gradually, through evolution, leads to standardization. As more protocols are written, this will become more scalable because there'll become fewer and fewer cases that are different from the standard, as there will be fewer special cases. You can almost think of it like a Markov chain absorption, like an absorption Markov chain, actually. So, you know, I don't want to go through the specifics here, but basically, what happens is, you know, you've got someone in a job like a junior, they can either get promoted or they can be fired. And, you know, they're kind of two absorption states. In a similar way, you can say with different phrasings, you can have people will approach different absorption states of being more like a standard or not like a standard, kind of staying away from it. But eventually, with time, if there's enough of this incentive, they'll be forced, well, not forced, but they'll be nudged toward the standard solutions. There may be more than one solution. That's why I say states. Those states may be, just like here, it's like we're leave or stay. It'll be one standard or another for different scientific reasons. There may be different needs to have different templates that have different fill-in words. So in this hackathon, what we did is we did some of this clustering of all these phrases, and just for my sake, I want to just emphasize that with the clustering we saw, for example, hemoglobin greater than 9 is a very common phrasing compared to greater than 8. You know, so we see a few patterns emerging and a few special constraints appear very much at the bottom there. And so what we can do is kind of create these templates where I made one that doesn't really need domain expertise, informed consent. You know, we see things like signed, dated informed consent, signed, written informed consent, written informed consent. These are real examples. Like, why not just have kind of, I mean, they all kind of mean the same thing essentially. And so you could have a template, something informed consent, and with time, people may, for example, just decide written informed consent is more popular, and they'll gravitate toward that, and the others will see that it's more popular, and so then they'll gravitate toward that. I'm going to kind of skip through some of this, but just to say that eventually these criteria ID will be, that each template will have an ID and a variant that's selected, kind of like in genomics you have a gene and a variant. And so it's a different way of thinking about it. Just like in genes you have letters, no one actually refers to genes by the actual letters, they refer to them by IDs. And then you give it a template. You give the score based on how you picked it. So maybe 100K gets a score of 100. We actually found this is an actual example. Someone typed in 100, it was an error basically. So that is not a good score, but they'll see that they should have picked 100,000. Or in some cases, you know, you got bone marrow, some other things that need a specific number. Like you might pick a slightly different number there. And let's see. So the final thing I wanted to add is that, you know, we've done this through now hackathons and a few initial pilots, and now we're looking at kind of taking it to the next level by running this 3-month project with the immediate office of the Secretary of HHS and GSA, and also involving some partners over at the VA through the Opportunity Project. So a project that we're really excited to begin within the next month in earnest, and also involving some of the entities under those agencies as well, including data from NCI and so forth. And so in summary, what we've been able to do is create these data sets that allow you to compare different trial matching approaches, apple to apple, so kind of like a way to compare NLP algorithms and so forth. We clustered the results based on Boolean logic and create these fill-in templates. But most importantly, design this framework for incentivizing standardization in criteria using this absorption Markov chain approach and consensus scoring for protocols, and then created a proof of concept for that. We actually found we're able to rectify a few issues and make suggestions to business processes, databases, and underlying protocol data as a result of this work, which was really great to improve processes, and they're now, as I said, preparing to launch this Opportunity Project to iterate. So I want to thank a lot of people that are involved. You know, I just put as many as we could really on the slide, but really thank everyone. There's our email, by the way, about if for this, or if people want to talk about some of the NLP kind of toolkit where we assemble feedback together.